Most people have encountered and even used mechanical fasteners in their daily life. However, you may be more accustomed to other names for these fasteners, such as bolts, rivets, or nails. They come in a wide range of sizes and materials, but they all have one thing in common. They connect parts together through mechanical interlocking, hence the term mechanical fastener. So what is mechanical interlocking? This term simply refers to the fact that load is transferred between the fastener and structure through contact. You can do this yourself by mechanically interlocking your hands by curling your fingers to join your hands. If you try and pull your hands apart, you can feel the contact forces between the fingers in each hand. This is the basic principle of mechanically fastened joints. The types of fasteners we use in engineering structures are broadly characterized by how they are installed. The first category is a threaded fastener, which uses a helical structure known as a thread to screw into a material or to interlock with a matching thread, such as in a nut. These types of fasteners have the advantage that they can be removed and reinstalled. However, as we will see later, this can sometimes also be a disadvantage. The second category is deformable fasteners, also commonly referred to as rivets. This type of fastener relies on plastically deforming material inserted through a hole in order to form a fastener head that is larger than the hole it was originally passed through. This type of fastener is relatively cheap to produce and forms a permanent connection between the two parts that cannot vibrate loose during operation. These 2 points make rivets one of the most common fastener types in the assembly of aircraft structures. The third category of fastener is known as blind fasteners. These fasteners are a specialized fastener designed to be installed with access to only one side of a joint. There are a wide variety of blind fastener types, some containing threads and others relying on plastic deformation, but they are all designed for one-sided installation. The last category of fastener is a nail, which is a pin that is pierced into a structure to form the interconnection. Nails are commonly used in many engineering and construction fields, but are generally not used in aerospace structures, so we will not discuss them any further here. In addition to the type of fastener, we can also categorize mechanically fastened joints based on the way the fastener is loaded. There are 2 primary loading modes possible for a mechanical fastener. A tension joint relies on load passing through the fastener along its axis, causing tensile stresses and elongation of the bolt. Conversely, a shear joint relies on load passing through the fastener perpendicular to its axis, causing shear deformation and shear stresses within the bolt. Let's take a closer look at some examples of mechanically fastened aerospace joints. Behind me is the metallic cockpit of a regional jet aircraft. Let's take a closer look at some of the joints on the surface of this cockpit. We can see a number of fasteners all over this aircraft, but here we see a particular riveted joint where a sheet here with 2 rows of rivets meets a sheet here with 2 rows of rivets, creating 4 rows of rivets. Let's take a closer look on the back side to see if we can figure out how this joint transfers load. Taking a look at the inside of this joint, we see our original upper or top skin panel that had those 2 rows of rivets. That is connected to this backing plate, and that backing plate connects to the lower 2 rows of rivets, as well as this stringer or stiffener into the lower skin panel. So load is transferred from one skin panel into a backer plate through shear, and then back into the lower skin panel. So this is an example of a shear joint, and if you take a closer look at the fasteners, you can actually see that they're plastically deformed to form these rivet heads. These are classical aerospace rivets. And if we back up a little bit, you can actually see that there are rivets all over the inside of the aircraft. It is one of the more common fastening techniques within an aircraft. Here we see a simpler example of the joint we saw in the fuselage, where you have one plate and another plate joined by a backing plate shown here. In this case, there's actually 3 rather than 2 rows of rivets attaching the 2 skin panels to the backing plate. And in this case, it uses a different fastener, a special fastener known as a high lock rather than a rivet. Also, you can see here that the joint has bent, as this one has actually been tested under extreme loading, causing the bending. But it illustrates an example of a shear joint where the load is transferred through these fasteners from shear from this upper plate to this backing plate and then back into this other skin panel. Now let's take a look at an example of a tensile joint. Above me here you see the spar of a Spitfire fighter aircraft. Let's take a closer look. There are a number of structural details on this spar, but we are going to look at one in particular. If we go down this spar, we can actually see a clip here that is bolted on. We have bolts connected to this structure where tensile load would be applied along here, transferring to tension within this bolt. These clips would then attach a rib to this spar. We can see a similar connection in a different rib to spar connection. This is actually for a horizontal stabilizer in a different aircraft. And here you see the rib, the leading edge of the rib, and it is connected at this flange to the spar. And if we look on the other side of this connection, we will actually see a threaded fastener that passes through here into this nut plate, which is equivalent to a nut in a threaded assembly that has been secured using smaller fasteners to the spar so that it stays in place, it won't fall out.